All right, so thank you very much for coming out to my talk here. I know this is probably not the sexiest topic in the world to go over, but this is the modern policy management, and we're going to be largely taking, the subtitle is placing responsibility where it belongs, but probably more appropriately. But instead, really what this is going to talk about is more about the automation of policy. So real quick, I'm not going to spend too much time on me, but this is me. You can see me up here too. I've been in the software industry for a long time, and so a lot of what I talk about is going to come from probably some historical elements of where we end up at, how we ended up here, and how it all came about. But outside of that, I'm kind of a whole-rounded person. I like to homebrew and snowboard, play hockey, that kind of fun stuff. So, all right. So today, what we're going to talk about is we're going to talk about first what are policies. So we'll normalize on what those are. We'll get through a little bit more about how you manage them, how companies and organizations manage. Eventually get into where are the problems that we typically exhibit or see in the organizations, and then how do we fix that? And if everything goes good, I'll do some demos. On my very first time giving this talk, I didn't have that little demo god thing, and it actually blew up on me. So I put it in, and it's worked ever since. So that's my good luck charm. So just a quick poll. How many of you guys like hearing the word policy management? Fantastic. I actually had one person raise a hand once, and I was like, you must be a security officer. They're like, yes, I am. So nobody. In fact, truthfully, when I brought this topic up to my team, they said, really? They're like, you want to talk about policy management? And they said, here's about 5 other things you could possibly talk about. And I was like, no, this is what I want to talk about. They said, okay, we trust you. So hopefully you guys will get something out of this, and you'll see the same thing that I do, that we're kind of on a new revolution of what we can do with software and policy managements. So first, we'll kind of just talk what are policies to begin with. So in basic, policies are really just a series of principles and basically statements of intent about what it is you want to do, and then some practices and procedures to follow those. So it's a pretty loose definition as to what a policy is. A policy has quite a few different elements to them. In order to make up something that's kind of cohesive, you always have to have a purpose and intent. That makes sense. You have actors, so who is participating in this policy? So is it a developer? Is it a machine? Is it a user? Things like that. Is it a government entity? We have responsibilities. Who actually is an actor? And the whole RACI, who's informed, who acts on it, who's responsible, etc. There's a scope. There always needs to be, how big is this policy going to be? Is it just for a development environment? Is it for everything? Is it just for a period of time? Then you have measurements. How effective is your policy? Can you actually do something to measure if it's effective? And the last bit is always has some sort of a scoping date on it. You don't want to have an open-ending policy that just will never end. So when we look at policies end up changing very, very frequently, and I want to point this out because this is important when we start talking about automation. So the policies have agility. You have to have agility with your policies to keep updating. For one, governments always come and go. There's always a new mayor. There's always a new president. There's a new legal bodies. Those things change. If we look at GDPR, it was implemented within roughly 2 years. So we think about these policies honestly have to keep moving very, very fast. So in order to achieve this, what we have to do is we have to think about policies as being separated from the decisions being separated from the actions. So I have an action, I know what needs to happen, but my decision can be made outside of that. I can have my policy created just like we would do for an implementation. So I'm not going to talk about HR policies. I'm probably the last person you want to hear about HR policy things. So I'm only focusing on just the technology-based policies. So if you do this, we can categorize our policies into basically 3 major categories. First one being a solution protection. We look at security as being a big overarching umbrella of policies, and then regulation and compliance. So if we look at the regulation and compliance first, the regulatory compliance really is the policies that are around legal, around industrial compliance, everything. Think GDPR. Think policies might be your data has to reside always in EU or always in a certain location. Those are those types of policies. Other ones you'll find too from a compliance perspective is you might have something where you go to your customer and you say, hey, we'll sign this deal, but in order to do that, we will ensure that all logins have multi-factor authentication or something along those lines. So you have a contractual agreement that you have to adhere to. Other things might be enforcing auditing as well. So that's what those mean. So a solution protection is probably the one that us developers are most commonly used to seeing. And a solution protection would be policies you put in place in order to maintain health and stability and reliability of your systems. So things like don't allow pods coming into Kubernetes that don't have a resource limit on them. Don't let new machines get spun up that will consume all of the resources in your cluster or in your network. Things like that. You can put together these policies. Other fun ones too are like don't let passwords and private certs be in your repositories. Those are all good policies to think about that are solution protection based. And oddly enough, security does actually play in all of them, but I have a security policy or a security categorization on purpose because there are things like, let's validate token scopes. Right now you get scopes to come back on your token. Well, you hope that that's exactly what it is, but sometimes you can want to add additional validation to it. Enforcing TLS, there's a lot of things around that. So basically the idea of a security is more or less to prevent the unintended use or exposure of your data or system. So now that we have a whole series of, we kind of understand what policies are, we have to talk about the management of policies. And so in managing of policies, it's really taking those policies, and it's important to state here that it's for creating, communicating, and maintaining these policies. So just maybe a quick question, how many people in your company do you have all three of those? Most of the time it's usually somebody creates them, you know that they create them somewhere, really poorly talked about, so you don't really hear the communication, and maintaining as well, they're probably in SharePoint. And once it goes into SharePoint, it's dead, so that always comes back to this is where the source of contention. And so when I put together this talk and I said, yeah, really you don't want to do policy management, the reason why is because the enforcement is the pain in the ass. This is the part where as a developer, you always feel like you get yelled at because you didn't know what the policy was and you should have had it and it just sucks. Nobody wants to be in there. So what we need to do is we need to start using tools to enforce our policies. Human-driven rules are not enough. Just going to your Scrum meeting and they're like, hey, did you remember don't put your stuff in another region or something like that. Human rules don't really work. And inevitably, it's usually done by a security officer who, quite honestly, doesn't really know much about technology or doesn't know the implementation of the technology. Often policies are putting a tooling together does provide a framework as well. And so if we start thinking about how we want to always go back to the same place to find out what our policies exist. And again, SharePoint is not a framework. And I won't beat them up too bad if SharePoint doesn't do a whole lot of things. So anyway, the last thing it also does is you can use this tooling to be able to do the measurement. The measurement part of a policy, you can use the tooling to say, I can now prove that I'm within compliance. I can prove that my policies are doing what they need to do. It really helps with audits. And if you take this back to your uppers in the company, this actually helps with operational cost as well. You don't need to have somebody come in and spend 6 to 9 months doing a huge audit of your system. But you can say, here's my policies and here's how we use them. So the enforcement, this is the not so fun part. So most of the time, policy enforcement happens from word of mouth. Every once in a while, you'll get them from an actual project will start and we'll say, hey, this is, GDPR is a great one because it's still fresh in everybody's mind. GDPR was, hey, let's have a project to ensure that our system is GDPR compliant. Most of the time, it's usually requirements come from somebody else. You just get your tickets, you do whatever you need to do, but you don't actually know the whole complete legal part of it, so you just do what's right in front of you. A lot of time, policies or adherence is temporal, meaning that you hear about them for the first 2 months of the new policy comes out, and then at that point, it's left your mind. Nobody wants to dwell on policies. So, enforcement methods. Most of the time, the companies for enforcement are going to use outside vendors or outside partners to come in and do an assessment on your application or your basically your whole suite, and they're usually not a part of the delivery organization. So they're looking at it not knowing how the software is actually put together. I hate to say it, I'm going to beat up a little bit on the CSSP folks, but they usually come in and just run a whole bunch of scripts and say, hey, here's a checklist of things that you didn't meet or didn't have. They don't really know how the software actually works. They tend to be very lengthy as well, and They're not a lot of fun to go through. So challenges we have, so lack of knowledge is probably the biggest part of policy enforcement. It's just not knowing what's there. The late cycle and is definitely plays into a big part of frustration for developers. And oddly enough, this is how I came up with this talk. A couple of years ago, I was in a client and I was talking about continuous delivery. Continuous delivery is everything to me. So I mention that in almost every talk I have. And probably, if you see me at the bar, I'll probably talk about it there too. So continuous delivery is important to me. And so what happened is I was talking with a client about how there's two different organizations that can stop a release from going out at any point in time. It's usually security, because they're like, hey, that's you're going to let things go out bad, and we're going to get breaches. Or it's legal, saying we're out of legal compliance, we're possibly at risk for some litigation. So in the way that we've always done software, those things always come at the very, very end. They're never at the beginning. And so you've done tons of work, everything's out, ready to go, and then compliance comes in and says, hey, this can't go out. That's a huge bummer. So that to me is one of the biggest challenges. Often the last part of it too is that we rarely test our own policies. We don't write test cases for that usually. So there's kind of two different ways in which we do policy enforcement. There's the upfront. There are some positives to that. When you're up front, you can change your architecture or design it to be much more, accepting of the policies you want to have. Again, so let's use the EU, US version of things. If it's only in EU, when you do your architecture to start, you plan for that ahead of time. That's a good thing. However, upfront enforcement of policies or creation does create some negatives, and these will be things like draconian rules. Thou shalt not do something. And when those start getting bigger and bigger, you stifle creativity and you start forgetting about good design practices, and you start doing, CYA instead, the cover your ass programming. So at the completion of a project, I try to come up with something nice to say about running policy management at the completion. And I said, at least you know what your usage patterns are. But other than that, I really don't have any good positives for doing enforcement at the end. At the end, there's a ton. I only listed 4 there, but there's probably 20 or 30 you can come up with. But it does increase your technical debt. And this is pretty apparent where you, at the completion of a project, you're about to go live, security comes in, or legal comes says you can't do something. Do you think you spend the time to actually refactor your work the right way it should be done? Nope. The first thing you do is I got to get out of this as quick as possible. You pile on a piece of crap on top of your code, and then another piece, and thus you start adding to your technical debt very quickly. So we don't tend to do that well. We're a little bit lazy. We not give them the time. So kind of my last segment here before we get into more of the modern side of things. So responsibilities exist all across the board for policy management, and I just listed out what I could think of here. So security engineers, and security officers, they do have the overall understanding of what needs to be done. It's probably important to note here that policies are business decisions. Policies are not, it's not law. You're not actually, if you don't comply to something, you could get a fine. That could be a business decision. So if your company says, I don't care about GDPR, and it's a hefty fine if you get caught, but you don't have to do it. So this is the security officers and legal to be able to say, this is what we should do to protect our business. So they're coming up with the rules and finding that out. IT administration is often responsible for enforcing the policies. Technical leadership is more there to make sure that we have the techniques and tools put in place. The developers and architects are ultimately responsible for developing those practices into the software that we write. Get down to QA, feel bad about them because they usually get dumped on at the end as well. And then product owners and the legal team both have aspects into the ownership of policies and enforcement as well. So what we end up usually doing is we end up having, just like everything, right? There's responsibility silos, or there's silos that exist. If I could do anything in this world, it would be starting to remove all silos out of development in general, start packing teams together that are much more useful. So what happens in the responsibility silos, like a CISP is not going to know things like how much RAM are you going to need for a particular application, or how much memory does it take, or what does it look like from a threading perspective, or disk size, or anything. They don't know about that. All they know is they have a certain responsibility. So when they put together these policies, they may not actually work at all with your system, or they might be only geared towards one of the categories. And we have 3 categories we always have to account for. Let's see. Information on policies is, again, not really shared. It's usually word of mouth, comes down, top people know about it, and they say, don't care, don't worry about it, just do what I say. So that creates quite a few lack of information. So basically, summarize where we currently are with policy management. It's accountability and responsibility is usually split between multiple different parties. The information is not shared well between them. Late changes are usually the action that we do in order to apply to a new policy or a change in policy, and it's very difficult to be able to prove those. So then with modern, what we want to do is we want to say, how do we solve those problems that we just kind of put together? So I'll take a small step back. Like, software is changing. We're doing things different now than what we did even a couple years ago. We have this concept called shift left that you're starting to hear more about, or maybe you're already on a team that's starting to do this. It's the idea that we have effective Scrum teams that have everything on the team that's needed at the time when you do the delivery. So, and what I mean by this is most of the time you're taking QA. This is a long time ago, right? QA has been a part of it. Actually, I'll get into that in a moment. The very specific. So, but this is kind of good representation of the splitting of the shifting responsibilities. IT organizations used to be a ticket-based system. They used to say they used to be a bottleneck within the delivery process. Excuse me. And so what would happen is everybody would have to, all these different delivery teams would have to go work with the IT systems and say, please get me a new service or do whatever, and it became a bottleneck. And QA was always a matrix organization, and so you had to wait for them to be able to complete the quality testing and whatnot. Perf and security, they're the furthest possible away for the entire delivery process, and so they know nothing that actually happens within it. They just know this checklist they have to hit. So now we're shifting to a new responsibility model where we have a team will be comprised of all of the people who are responsible for the software delivery, and ops now becomes a support for those teams rather than the bottleneck. So the cool thing, probably the best thing that keeps coming out about modern software delivery is that we're focusing on fast feedback. And so we have it from delivery, and what we can start doing now is rather than just waiting for security and compliance auditing, let's add that into our feedback and put that into our feedback cycle. So when I first started programming, it was quite a few years ago, I remember dropping files into a shared file system and going home the next day, coming back, and somebody compiled the code and said, hey, it didn't compile. And that was not very efficient. So we came up with continuous integration as an industry, and we started using that. So that at least allowed us to do some level of compilation between all of our code. We did some real basic testing at the time. So then we said, let's take it one step further. Let's actually say, can we actually deploy this after we made that change happen? And so continuous delivery came out, and with or without manual aspects, I won't go into those details of that, but the concept of being able to change your code and push it out. Then we said, okay, well, now that I have it to a noble stage, what happens if I actually push this out to a production? Keep in mind here that I have things like provisioning of infrastructure is not in there, security and compliance. This is where we were a few years ago. Then we said, okay, well, what about if we can start saying, let's bring the infrastructure into our pipeline as well, or into our delivery process. And infrastructure as code was kind of born, or at least the provisioning tools at first, like Chef and Puppet, but then it moved into more Terraform and tools like that. And so now we can now automate the entire process all the way up to, and yet we still don't have security and compliance in there. So then we said, all right, let's bring in security. This is where DevSecOps comes in. This is where you're doing multiple different tiers and layers in your CI/CD pipeline to ensure that you hit, or that you have a secure product going out. This is one of the compliance levels, or one of the policy levels right here. You may not realize that you're doing it, but things like, let's make sure we don't release vulnerable, or code that has common vulnerabilities and exposures, or CVEs. That's done in the security. So I didn't have a name for this. I don't know, I just call it delivery ecosystem. It's kind of lame, I'm sorry. But that's the name I came up with. But this is where we say, all right, let's bring that compliance back into our delivery pipeline. So cool thing here is that if we really look at the CI/CD pipeline, we can apply policy management at every single aspect of that. There's something that can happen at every single one of these events. So building, you could look at building and say, I have to always have, always has to compile, right? Or I have static code analysis, and I have to have a certain number of a threshold that I can't hit, that if I go over, we fail the build. Unit test, maybe that's an enforcement of 80% code coverage or 60% branch coverage or something along that. You can write a policy for those things. Acceptance tests all the way up, right? Provisioning of infrastructure, can't deploy to certain locations or can't deploy certain sizes or into certain environments, all the way through that. There's really cool things you can kind of pick and choose throughout that. Now, up until now, we've basically done everything in, like, that is going to be largely distributed across the board for different tool sets that you use to make these policies happen. what we're starting to get closer to is we are getting closer and closer to single style code bases that will allow us to write our policies and be able to put them in and use a similar tool. So modern policy management is performance minded, because if you think about that entire pipeline I just showed, if it takes calling home every single time you want to do something, you put a big bottleneck and a single point of failure in your system. And that's not a good goal, and we're smarter than that now. You want to be able to enable your developers. Again, I don't want all the developers to know every single aspect of all the different rules. What I want them to know is I can check to see what the policy is from a code perspective, and it will succeed or fail, and I get to move on. I get to handle that action based off of the response that I get back, but I don't need to actually know the policy. And then you want to also make it so it's transparent. So again, everybody in the organization should be able to go to some place and say, I see the policy, I see the code that's written for it, and we can use it. Now, when we have these digital side of the policies, we have things like policy as code, and I'm going to introduce that in a slide or two here. And then we have to make sure that it's testable, and I'm going to show you how we do that. We want it to make sure it's extensible and it hits all of the different policies, or it's available to all the different policy categorizations. So again, it's security and compliance and safety for your system, and what the last one was. Oh. All right, so I'm going to introduce what's called Open Policy Agent. This tool's been around for a little over a year and a half now. It's been implemented by quite a few very early adopters, at least in the US at this point. Open Policy Agent is a CNCF project. It's in incubation stage. And what it is it's just a distributed decision engine. That's pretty much it. So it's really, really flexible. The architecture kind of looks like the diagram I have there. You have data that can be added into an aggregation service. The actual agents run on the machines or as close as possible to where the decision needs to be made, is what you try to shoot for. There are newer versions that you can set up to be more of a single point of failure. So you can tell I'm already slightly opinionated and not having a service that you call back to, but you could set it up very easily. Now what it does, it takes these policies, you import them in with the policy portal, and you push them out to the different agents. They have a whole packaging system, they call them bundles, and put those all out there. So you could have thousands of these different decision engines that exist. So the data come in might be things like employee information. Maybe you want to check against an employee information or check against orders, or who knows, right? There's a ton of different things. So basically what it tries to solve is you're trying to solve the decision making at the last possible second. Now, the language gets used is called Rego, and I'm going to cover that next here. Rego, I will say, it's based off of, actually I don't remember where, wait, do I have it up there? Nope, I don't. I can't remember exactly what it's derived off of, but it's a very old language. And what it is it's think of it more like a query language than anything else. And so in my example here, there's a couple basics, and there's really good documentation on the OPA page. But the concept here kind of looks like at the top, I'm defining a rule. My rule is called validation, and I have outputs. Again, if you're a programmer and you have outputs and inputs, and you read the clean code book, it feels really awkward to you, but just go with it. Then you have what are assignments below there. So I'm looking at provided and required and missing. Those are assignments, assignment variables. And then I'm doing a conditional test. In this case here, I'm just doing count missing is greater than 1 or greater than 0. So it's 1 or more. Everything that is not an assignment is a part of the rule or the policy. And so if that is true, then my entire validation is true. If I had multiple lines, so I said maybe its count is greater, missing ones are greater than 0, and it has to contain a certain flag or something like that. If I had multiple statements, both of those would have to be true in order for the policy to be true. So we can effectively basically look at this, take this, and start thinking about how we can convert our policies and put them into a piece of code. Now, the testing framework out there is still a little immature at this point. This product's still pretty early, but there is a unit testing framework, and I'll do that in a demonstration here in a few minutes. Ways you can extend it further is you can use like BATS for the Bash automated testing framework if you want to make it a little bit more robust. Just might be an example of something that I've done in the past to make that easier. So, oops, I forgot to take out the beer pitcher. So ignore the beer pitcher. I grew up in Colorado, so we had this bad beer called Coors Light, and they call it the silver bullet. So Open Policy AG is not a silver bullet. And what that means is that it's not made to make all decisions. Be very specific about the types of decisions you want it to be or what the policies are for you. It's not good at carrying a ton of information. So if you have a database of 30,000 customers or 100,000 customers, when OPA takes the data, they pull it in, they'll put most of that into memory, so that way it's very, very fast. The goal is to have decisions made in 20 milliseconds or so. So you want it to be really quick. So the more data you have, that means the more memory you end up taking up and consuming for your policy. So it's not an agent that will do everything. The syntax is a little bit more difficult to work with until you start to really understand what it means by you're selecting everything as you're doing this. So, and most importantly, it's not meant for authentication. So you don't use it as this is a user's login and this is how they get it. Do the authentication somewhere else. Use this for more authorization. So some best practices, you want to seek feedback as quickly as possible. So have these agents running, have these policies existing, and get that feedback the moment something happens. Don't wait for something to go to an environment to find out that it violates a policy. Pick the right types of tooling. So in 2 slides here, I'm going to show a whole bunch of other tools that help kind of adhere to or help you enforce the policies from a code perspective. Pick the right tools for the right jobs. OPA is incredibly flexible and very useful in a lot of ways, but it's not everything. Let's see. Oh yeah, another thing I probably didn't talk about too much yet, but when you're constructing these policies as code, think about how you construct a policy to be more algorithmic based rather than binary based. If it's just yes or no, you tend to always put the right data. You're looking for a very specific answer. You can still answer a binary question in an algorithm by saying, is it above a certain number, yes or no, but try to think about it from an algorithmic perspective and not just a if has, else lose sort of thing. So here's a whole bunch of other tools that are available now that solve different aspects. So in the Kubernetes world, you have things like network policy. Those are code-based that you can use to say what talks to what. If you're in the Istio world, same sort of deal with the different destination routes and whatnot. You can restrict quite a few different communication methods. OpenShift does have what they call policies. Those are really useful. Terraform, my example I'm going to show in a few moments here, is Terraform based. But if you're using the Terraform Enterprise, you have what's called Sentinel. It's actually a really good project. And it works very well for enforcing policies. But the other thing is that it only works in Terraform. So everything on this list only works for those specific tools. I do want to point out another thing too that's a policy that you may or may not recognize, but if you use BDD security or Gauntlet or something along those lines for DevSecOps, you can build tests that are specific to just these security things you want to do, like container goes out, validate that it only has certain port open, or that it has access to a certain folder, things like that. You can enforce those with code. It's a great tool, so that's another thing that kind of layers in. Oh, and the very bottom one, OS Query. That's actually how I started all this. Is I didn't know that there was an open policy agent project out there, and so I said, hey, I wonder if I can do something that will collect all the information. I can make queries off of it. And OS Query is a great tool to do that with. It just runs an agent and reports back a whole bunch of metadata about the server and services that you have attached to the agent. But then I would have had to do all the work, and OPA was a lot easier. So with all that, I'm going to try to do 3 different demonstrations here. I checked them earlier. They should work. And good, I'm on time, so this is fantastic. Oh, by the way, if you have questions, I'll just raise the hands, but they also have the Slido, too, if you want to write anything there. So what I'm going to do is I'm just going to show you the framework for unit testing. Because like with all code, anything that goes into code, and I'm a true full believer that everything should be in code, 100%. Got whole other talks on GitOps and other things that I think are highly important to do this. So what I'm going to try and show is like, what does the framework look like? And it is a little bit immature. So I'll just show you, well, that's a lot of extra text I didn't expect to have happen. Effectively, this is the only line I'm running. So there is a test. So there's a CLI tool called OPA. It allows you to do all of your building of it actually has it's a full RPL tool. You can go in, you can create your policies on the fly, test them out, try the different data, get it to where you want to, then create the file, and then you can go run test against it. So what I'm doing here is I'm going to be using the actual test agent to run that. So if I do just run it, what the output looks like here, it says, here's my exam, or basically what my test looks like, and did I pass or fail, and I have some other things. So if I do cat policy test rego, this is what a test looks like. Up above here, this is my data that I'm passing in. So this would be on that diagram that I had of the data on the far right. The data would be, in this case, people, and I have Bob and I have Alice, and they have different flags on them for the test. So then down here in my test, I can say I want to allow with the input I have above, allow, and then and run the test against this particular use case. And then same with the others, where this one the opposite would be not allow. And so I get to test those. So that's how the unit testing works. It is a little bit I guess new, and they don't have all of the things like X unit based X unit based frameworks have a lot better output. They have also collected into the right type of same format and stuff. So it's not that mature, but they're working on it. Now, the other way you can also do this here is you can also do an eval. So an eval is just like you would if you had a server running and you wanted to run data against it, or this is what actually happens when you run this against as the agent. This is how you validate your checks here. I'm an OPA eval, I'm passing the data I wanted, and then here's the information that I'm passing in. So in this case here, it's just saying, I have a JSON file, and then run the policy, and this one has admin. That's the basis of that. So it's super basic. So that's a real high-level overview as to what it is. So it's kind of fun. So this is the kind of the diagram of how that will look out. So now I'm going to do something that's probably a lot more useful, and this is actually demonstrating Terraform. And so this would be the example I want to give is the Terraform. You want to make sure that you don't give your developers the ability to deploy into regions that you don't want to have them deploy information into. So this is going to give fast feedback. Ideally, all of these would be run in a CI. I'm not going to sit there and check something in and wait forever. That's not a good presentation model. So let me just kind of lay out what I have here. So I already have an existing Terraform local state going because I don't want to, again, start all that to start with. So I have a main file, main TF file. There's nothing super special about this. Just basic normal stuff. I'm creating a Google project, and I'm creating a container instance, and I'm passing in the region and zone. So that way, this is something that will look like something you would actually do. All right, so what my demo is going to do here is in the background, it's now going out to Terraform, saying it's running Terraform plan. So it's looking at the plan, and it's capturing that plan. There's a command called Terraform show, and it allows you to take the plan and convert it into JSON format. Rego does not know how to handle the direct output of a plan, so it will use JSON. So in the background, I take the plan, convert it into something. That's what the plan was here, and it should actually. Where's my region? Sorry, this is really long. I try to get the smallest, right? So Europe North 1B, that's my zone. And so when I run that plan against my Rego here, or against my OPA, is valid region, I get back the response true. So that's all good, right? So now, if it's over there. Whoa, yeah. So from here, instead what I'm going to do is I'm going to comment out these guys here. I'm going to run the other version of it where I'm passing in the other region. So note here, or what's important on the note here, is that I'm passing in variables by command line just to overly demonstrate that it's going to a different region, right? So rerunning it here, but I'm using US instead of EU for my policy. So it does the plan. Validate it, and now you see that I have a false. So if this is in your CI/CD pipeline, you can reject the builds that have the Terraform in it to make sure that you don't deploy outside of the regions you want. So that's that one. That one's pretty fun. And now the last one is Kubernetes, just because I wanted to have Kubernetes involved here. So when I first started this, you had to use an admission controller originally, and so I think my diagram, no, it doesn't good. The way that you would check everything coming in is you'd have to an admission controller. It would then reach out to OPA, to the local, and say, does this violate one of my policies, and come back. They scrapped that in April, and they came out with what's called Gatekeeper now. So it's an actual managed operator that exists within the Kubernetes cluster, and so it's a hell of a lot easier to work with. So what I'm going to demonstrate here is I'm just going to create a policy that basically says I can't deploy into default. I have to deploy into something other than default. And that should be a good rule. Other good rules in Kubernetes are things like on all services require an email. as an annotation. So that way, when you start getting to hundreds of services in a cluster, you should be able to know what team built that and what an email so they can go back for accountability purposes. Or if you're doing metrics, if you have Prometheus and you want to ensure that everybody has that, make a policy that forces or that ensures that all services have the annotations for the metric scraper. Just a good example. So to demonstrate this here, I'm going to do so demo deployment here. So I'm just going to have a demo deployment. The demo deployment does, it just puts up, I think, an Nginx container. I don't really care what goes into it. It's just more that for demonstration purposes. By default, while apparently network is always going to be slow on these things, I'll just wait for a sec here. It'll come up, I hope. There we go. So it created my demo. So if I do that, you can see that I'm here. By default, you see I don't have a namespace set. So you can see that I have, in this case, Istio is running, so there's a sidecar to it. So, all right. So I'll go and delete it, and then what I'll do is I'll actually run. I'll show you the code here for the policy management that's in there. I've already installed the operator. There's no sense in showing how to do that at this point. It's dead simple to do. But I want to show you what the policies look like. So namespace required. So there's a CRDs, because it's an operator, so they create their own CRDs for what the policies need to look like. In this case here, this is what wow, that really doesn't do well. Sorry, it's not very high up there, but it shows that I've created a Kubernetes required namespace is what we're calling it, because we had defined that in CRD, and then I say it's applied to basically every single type of item that you want to have come in, and then how do you want to group it. So this just sets what that is. In the template itself, which is the other file, it shows the rego. So, and then I'll go ahead and run these guys here. Let's see. So then here's my constraint. So here's the type that I'm creating. It's a Kubernetes required namespace, and you can see my rego down here at the bottom. Basically, I'm saying I want to get the input, which is the data coming in, review, object, metadata. That's the JSON path to get to the namespace. And then if the namespace is equal to default, it's false. This is if it's false, then it will reject it. If it's true, then it's going to accept it. So this is how it comes back. And then we're setting the value saying the namespace needs to be set. So just real briefly. Let's see. Actually, I have it in here. Oops, I don't know what that ends on there for. All right, so now I'm creating both the namespace required template, and I'm going to do this in the background. It's also doing the other one. Man, I did not think this is going to run that slow. So maybe while I wait here, any questions?
Question is, who is responsible for creating this policy? Is it just developer or combination developer, security guy, or just security guy?
So it could be both. Ideally, having a developer implement that is probably better to start with, because it's not an easy language. And again, like I don't think most CISP folks can do a lot of programming, but it's ultimately their responsibility. And if we keep going down this path where we expose these text files out, they should be able to start learning that language, and so they can manage those. Again, so the developers don't have to care. All they care is that the policy was created and they're checking against a known policy, by name or something. All right. So I'm going to go ahead and try to deploy the exact same default demo there, and you'll see that I was denied, and you'll see my message here is it must provide a namespace other than default. So if I do, so if I go in here and I take out and I, oops. And then I go ahead and rerun it here with a defined namespace, although the namespace may not exist. Oh no, it does. Okay, good. Like that would be a bad demo. Yeah, so now you see that I have my namespace. The file actually was created, or I'm sorry, the pod was allowed to be added in. So this is a good demonstration, just a very, very basic one. But think about anything that you could do within Kubernetes, like resource limits and annotations, and maybe maybe it's the person who's submitting the account that's coming on, because you get the RBAC information. There's a lot of things you could possibly put into policies. Try not to make them super draconian, but think about how you're doing that for system protection. So to kind of summarize everything up, the whole goal of doing policy management in an automated fashion or with code is really to make sure that we have transparency. We want to find and remove the silos that exist. Bring that early feedback as quick as possible into your delivery process. Don't allow a security team to come in at the very end and say you can't deploy this because you have something that could have been automated into the system. Implement everything into CI/CD pipelines. Make everything as code. Let's see. Yep. Oh, and the last thing, remember also that policy management isn't a checklist. These are business decisions that need to be made. So make sure you are pushing your company to understand that you need to know the business decision on how you do it, and then implement your policies from there. So that's all I have, and right on time. Any questions? Sure. They tend to be inflexible. So what I found is that a lot of the time a policy might be like, so think of like region, right? So I showed the region from the example of Terraform. So if your policy is in EU basically, and now all of a sudden you're like, well, actually Asia's okay, then it'll be is in EU or Asia, and so you're thinking about it from a binary format rather than saying collecting that, is it in a group? If your group has only one in it, but it's in a group, it's a lot easier to extend and make it more useful. Any other questions? Was this better than what you thought it was going to be? Yeah. Thank you. I think it's super useful, and I really do think that fundamentally believe that we will be talking about this for the next several years as developers, because we finally have the capability of doing this in code. So, all right, with that, thank you. Feel free to come to our booth too and chat.